Ladies and gentlemen, welcome to our webinar series iTAC Live on Stage. Today we want to talk about the requirements and challenges in e-mobility. For sure not about ranges, number of available charging stations, charging times and so on. So the common problems when you use a car. Now we want to focus more on the production IT requirements and the production process itself. Because we are talking about manufacturing issues, and maybe we should introduce ourselves first briefly. My name is Andreas Rudel. I'm working now for more than 20 years for iTAC, and I'm head of sales. And will you introduce yourself?
Yes, hello, my name is Andreas Rudel. I work almost 5 years for the iTAC software. And I'm working in the Department of Professional Services and consult our automotive customers.
Yeah, here first an outlook of our webinar series. Today we want to talk about e-mobility, as mentioned already, and therefore about the compliance regulations and how we can fulfill such regulations with our MES MOM system, the iTAC MOM suite. Let's have a look to the agenda. So for sure, when we talk about e-mobility, we want to touch briefly also the battery production. My colleague will then talk about the challenges in the production of an electric motor and also the challenges with the production of an electronic control unit. For sure, we give you our explanation, what is our understanding when we talk about compliance and what does it mean when you use a manufacturing system and when you implement it and how it helps you. And when we talk about how it helps, then we talk about benefits for sure later on. And for sure, we have a Q&A session. So you're invited to raise your questions, and we will try to answer all the questions at the end of our webinar. And please feel free to raise the questions.
Yes, the question can be raised on the right side of the screen. There is a chat box where you can insert your question. On the left side, you will find additional information of the planned webinars.
Yeah, e-mobility. I guess everybody knows about the climatic change and the political restrictions. They are stronger and stronger and forcing each of us to change the behavior for individual mobility. Though it needs to be environmentally friendly in the future, and as a result of it, we have to focus to shift more to e-cars, not to use any more so much gas cars. And at least if we want to drive carbon-free locally during operation, then it's right now the only option. And that was the reason why we thought it would be a good idea to talk about e-mobility requirements also from the production point of view. And as you see here in the slide from the VDMA, and especially if you focus on Europe, we expect in the next years a lot of new battery production facilities and also electric motor production and assembly facilities, because we are lagging up here really, and we have a lot of catching up to do to meet with the targets for 2030. As you see here in the graphic, in 2020 the output was about 5 gigawatt hours per year, and we have to go to a level of 125 gigawatt hours per year, and that means we have to have a dramatically growth. And that's the reason why we want to talk about the production process here for the e-mobility. Yeah, battery production, the entire process from cell production for module assembly and also the e-motor assembly, last but not least, is really complex, and you're facing a lot of issues here. And you have a lot of quality critical processes we have to manage with a production system, with an MES system. and the specifications which are given, they must be fulfilled. And thus the whole compliance must be ensured. But we will talk about later what is our understanding for compliance. Yeah, what are the challenges here? So when we see the challenges, we have to ensure the compliance, and we talk about process parameters. We have to provide to control the dedicated processes, but we have also to receive parameters. We have to take care for processing times, so we have minimum, maximum times for certain processes. We have to make sure that we are using the right material and only valid material, not block material, and the right material. If we look at a bill of material, that is a must that we are producing according to specification. We have to handle for sure versions and variants during the whole assembly process and the installation. We have to provide or you have to provide for your customers, when you have a battery plant, a holistic traceability from goods receiving to the complete assembled module of the battery. Classification is main issue. So that means the cells deliver a different performance, so it needs to be classified. And yeah, you have to manage this. Guidance, limitation of retest and rework is a requirement, and you have to manage how many cycles are allowed, for instance. Integrated locking. So if something goes wrong, you have to make sure that the wrong parts or the bad parts not go further. And last but not least, you have to take care and have to look at profitability. So that means we have to catch up also machine conditions, and we need to calculate KPIs, because only when you know where you are, you have a chance to be better in the future. So that are the main pain points. And yeah, if we have a look on the e-mobility manufacturing process in the battery production, so we have time-critical process to manage. We have to meet the specifications, or we have to document everything. And we probably get also a large amount of data, so a large data volume. And if we have a look at the electrode production and, for instance, the mixing process, there are a lot of data which comes up. And we have here continuous process and batch process. So that means there can, in a huge battery fab with, let's say, 10 gigawatt hours per year in output, and when we have, let's assume 100,000 parameters, or more than 100,000, even more than 100,000 parameters events per minute, that ends up in several hundred terabytes of data per year. So, and therefore our IoT Edge solution can be used for this purpose. And at this point, I would like to refer to our next webinar, which takes place on the 8th of February. And my colleague Martin Strempel and Jörg Both will explain the details for the solution. Here we will explain our IT solution in the integration of an appropriate sensor technology and the resulting advantage of an integration into a standard MES. So that means in the landscape, it goes hand in hand with also an integrated AI and data analytics tool, and that helps you really to optimize your production process. Okay, then let's have a look into the IoT Edge. I just opened the iTAC workbench, which is a user interface to use the application. I have just to log in here with my user, or here already predefined user, and then the system comes up and shows me different applications. And I go just to the add-ons area, and within the add-ons area we can find the IoT Edge. I just click on the IoT Edge and the software starts. So we are here on the landing page of our IoT Edge, and there I have different groups and area for alarms and so on. I just go to the groups, and there I go to the section for battery production. And as you can see here, if I go now into the overview, we see here the different processes. So we have here continuous or batch processes, more or less, and you can see here the mixing, the coating, calendaring, and so on. So it's a kind of dashboard, and you have an area where you see the previous alarms from the last time. And if we want to know now more details, we can just click, for instance, to the mixing area, and there we see now the relevant data. For sure, yeah, what you can see here is some integration charts and the relevant parameters, like the slurry viscosity, the slurry density, and that are, I guess, some of the most relevant parameters you want to see. And as you can see here, we collecting the data every second. So that that allows us with our device here to collect more than 100,000 parameters or events per minute. And that's what you are looking for usually in continuous or in batch production. Yeah, you may have recognized that we are working here with a traffic light with black, yellow, and red. That is due to the circumstance that we have in the studio here is green screen technology. So that means everything what is usually green is showing black in the demonstration here. But don't wonder about. But that's given to the technology. So right now we want to talk about the electric motor itself and the assembly process, and so I will hand over to my colleague Andreas.
Yes, thank you, Andreas. Let's take a look away from the battery onto characteristics of an electric vehicle. For example, the electronic control unit and the electric engine consisting of rotor and stator. We can say that these products are already successfully integrated and produced with iTAC. In the following minutes, I would like to show the manufacturing process of these three assembles and highlight some features and requirements. What we see here is a generalized assembly flow for the production of a rotor with examples of necessary work steps. Starting with the initial serialization, we can fulfill customer requirements regarding structure and content of the serial number. Usually, company internal guidelines of serialization guarantee uniqueness for the generated ID. During general assembly, we can identify three different types of components. Raw materials, such as the classic screw, nut, and washer. Small assemblies that have been pre-assembled by the supplier and serialized. And of course, assemblies that are already being produced with iTAC, and iTAC is aware about the production details of these products. For raw materials in our rotor line, like the permanent magnets, which are fed to the machine as a bulk material, we prevent excessive batch mixing by only releasing the refill procedure when the reported fill level reach a dedicated level. Small assemblies with supplier serialization can also be checked via part number against bill of material demands. The existing serialization will be documented in the system in relation of the used master serial number. The bill of material demands are based by the activated production order, which is usually imported by an ERP system to the MES. Also, the demand and sequence of necessary work steps got given by the work plan as part of the production order. By booking the state of the unit for the work step, time requirements such as cooling time or curing times for gluing processes can be monitored and observed at a subsequent work step. Let's take a look at the counterpart of the rotor, the stator. We see similar requirements such as batch tracking and the measuring of temperature curves during heating processes. But also the repeating test and inspection work steps, most triggered by end customer driven quality regulations, standards or certifications. These processes increase the requirements for the implementation. In future, tools like low-code will be used to create digital worker guidance and ensure the implementation of inspection and test work steps. In the stator production, as well as in the rotor production, special importance is attached to the specification and documentation of the machine parameters. These so-called receipts are stored in the MES in a document management module and can be read and written by the machine. Changes by the operator on the machine level are only accepted if the changes are uploaded and confirmed by the MES. In the production process, special work steps can always be identified that have a particular effect on the subsequent properties of the product, or due to their effect, make disassembly difficult or impossible. These work steps represent milestones and can be classified accordingly in the work plan. Repetitive thermal operations such as welding or tempering will influence the dimensional accuracy of a product, but also machining operations like turning, milling, or grinding cannot be run as often as desired. In this case, the allowed number of rework cycles need to be observed. For each incorrect cycle, we are able to transfer via machine communication or HMI clients detailed error information that can be used to identify the correct rework strategy. For client interfaces, the selection of available plugin modules for the iTAC workbench has been expanded. If we take a look at the manufacturing process of an electronic control unit, we see a probably familiar process to some of the listeners, the SMT process, which whose integration iTAC had its beginnings. One major point are the standardized interfaces with leading machine vendors of this market, which generate a big advantage in integration and communication. A special requirement of this hybrid production, starting from the SMT process to pre-assembly, assembly, and the final end-of-line module, are repeating cycle testers marked with a red dot in our graphic, where the component is temperatured, contacted, and tested. The test cycles produce a significant amount of product data, which provide the potential for analytic evaluation methods. Currently, the integration of such quality evaluation systems has already taken place. iTAC internal solution, such as the IIoT Edge that we saw in the earlier video, can be used, but also the possibility of customer and third-party system integrations is possible. These systems transfer their evaluation result back to the MES, and here it is invaluable to be able to identify potential faulty parts at an early stage, but also make influencing factors such as wear and tear of operating resources, equipment, or the machine transparent. If you're interested in the topic IIoT, please follow our webinar 3 at the 8th of February. The manufacturing process of such an electronic control unit, which involves up to 60 individual work steps, can be separated to smaller product and order levels in the integration with iTAC, which result into effort for planning of major and sub-production orders. This shows the high relevance of the interaction between MES and RPS, where our two-gun plan can be used for simulation and planning of production orders. But the best planning is no help if there is a lack of overview, transparency and flexibility on the shop floor. Our colleague Jens Rick will therefore go into more details on the flexible production webinar at the end of June. In times of increasing cost competition, the production of different components of a final assembly part are often not located at the same production location. During mounting procedure in the target plant, the correct component state need to be evaluated. The integration of iTAC across several plants is a big advantage here, because mounting verification can be done between different plants at one MES instance and even between different MES instances. The installation of a component from another plant we will see in a later demonstration. Let's first have a look onto an overview of these three main assemblies which make up our electrical engine. It shows that the electronic control unit has a significant share in the traceability data. The cycle testers in particular have a major impact on the 5,000 to 8,000 measurement data points that are transferred to us. The data presented are reference values from various iTAC implementations. The total picture of for an electrical engine shows about 9,000 to 14,000 measurement data points, up to 170 different raw materials, and up to 20 sub-assemblies, available with just one single serial number. Before we take a look at the assembly procedure of such components in the workbench, we will step to the topic of compliance, and I will hand over to my colleague Andreas.
Okay, thank you. Yeah, compliance. What does it mean when we talk about manufacturing process? Well, mainly we have to talk about the fact that we need to produce according to specification. But what does it mean in detail? We prepared here an example when we have a structure of the e-motor or e-engine. So let's say we have a multi-level serialized production. That is the situation we are facing. And if we start with the ECU, then we have for sure here several components. So the PCB, the IC, the sensor, and tons of other components for sure. Yeah, all these parts have already part numbers given by the ERP system or by the SAP system. Such data will be handed over via interface into the MES. So not only the part data for sure, as well the bill of material, the work plan, the production order itself for sure. It's a whole package. But we need it at the base because that's the master data we need to know, because that's the base for us to be able to produce according to specification. Okay, now the ECU maybe is living, so that means you have to deal with change nodes. The change node can be driven by your own development or by your customer, which is forcing a change on the product. So that means you have to deal with product versions or revisions. Does that mean that the system must handle it clearly and must be able to differentiate clearly older version from newer version? So when we look then at the test program, so that means when the hardware changes, maybe the test program version needs also be to adapted. So the production management system needs to handle the test program version as well. Then, for sure, we have the firmware version, which needs to get into the product, into the ECU, that will be flashed. And there, for sure, you don't want to manage usually into the BOM version because it's a different lane, so to say. So we have to manage an own firmware version in our software. And last but not least, we have the firmware parameters, which are defining how the product is doing in operation. And then, if we think about that, we have given a serial number, and we have made a setup for the material here in that example for the IC. So we have just scanned the material bin or the reel with the number 1, 2, 3, 4. Behind that, the batch or the material lot is available, the date code is available, the quantity, the supplier, the vendor, and some other attributes we may need. So we have every information aligned with the serial number from all components and also all process data. And if you look further now to the whole E-engine, then we have the situation that we have to assemble the rotor as well. Here the same story. We have as well to manage versions. We have components behind, same for the stator. Also a version which needs to be managed, and on the E-engine level, on the BOM level for the E-engine itself, we have to make sure that only the proven versions from rotor, stator, and ECU can be assembled to the final product, to the E-engine. And you maybe have here software versions as well. And what does it mean from the compliance point of view? So that means we have to make a setup check. So the physical setup of the material needs to reflect the bill of material. So we have a setup verification against the master data. We make sure that we are not using blocked material, because with blocked material you have maybe a problem with the product. We make also sure within the software that we are using the correct test version. And for sure that the correct firmware version will be flashed on a certain station. The correct production parameters, which we are providing for certain stations or certain processes, are relevant and will be managed by the system. And for manual processes, we can provide the right documents for the operators for the product. And so we make in an automatically highly integrated environment the conformance happen, and also for manual process. And let's assume the ECU has been produced in plant A and the final assembly will be done in plant B. So that means we have to manage the status as well for the sub-assemblies and the final assembly. So that means we have to make sure that master and slave serial number are really pass, if both status pass, that they could be assembled and used. And if you manage serial numbers, for instance, by line or by plant and not across several plants, it can happen that duplets or redundant serial numbers can occur. So we have to avoid that, and the system can manage that and will make sure that you will never have redundant serial numbers. And we ensure finally that the final product works smoothly. So that means we have ensured that we have only functional versions. Okay, now I want to hand over to my colleague again, to Andreas. He will show in our iTAC workbench and a manual process how that can work.
Thank you, Andreas. Okay, we are back in the iTAC workbench. The workbench is our HTML framework for standard and customer-specific plugin modules. These plugin modules can be used to create applications in a service that can be reached by the operator. For example, here we will today use the HMI module, and we will start with the TR module. In the TR module, we want to go into the unit history for a serial number that I already prepared. This serial number should display the E-engine, and as you can see, there are already booked work steps available in the bigger history. I already merged the stator and the rotor component to the master of the E-engine. You can see here the entries serial number rotor, serial number stator, and we have an additional entry that displays the product level merge in the rotor line, because the rotor line has 2 work order levels. In an additional register, we have an overview about the mounted materials. The mounted materials are the raw materials like the magnet, glue, or the housing. What we want to do next is we will merge the ECU as component to the E-engine. That's why I will go to the HMI plugin, and we will check if we already have a setup of the correct raw material for this work step, because to assemble the rotor we need some screws. Okay, in our situation the setup is valid and we can go to the mounting. I will first of all insert the serial number that is coming from the E-engine, and I will get the possibility to choose which part I want to merge, in our case the ECU, and will insert the ECU serial number into the field. After confirming with install serial number, we release the mounting, and the mounting was successful. Due to the successful mounting, we want to book the state. That's why I insert the serial number into the input field for the state booking. We want to book pass, so I will register the serial number and book the state. Afterwards, we can go back to the TR module and refresh our site. And we will see that the ECU is available as mounted unit for the E-engine. For the ECU, there were even some mounted materials available. So, for example, like here, the THT LED or the connector. Okay, that was an example of the merge between 2 sites for our assembly of the E-engine. Again, the note, if there are questions, please insert them into our chat box and we will take a look on this at the Q&A session. Yeah, the next topics are the benefits. And Andreas, what kind of opportunities for manufacturers with MES or MOM solutions do you see?
Yeah, well, we have seen before that we can really do the whole process control and mapping the entire production process into one solution and one system. So that means we have an end-to-end solution which is able to manage really batch production or continuous production with the IoT edge, where we usually facing a huge amount of data which needs to be managed. Then if you look further to the assembly processes, so we can manage here as you have shown it right now, and I think that's a big benefit to manage all the production process for the e-mobility in one system.
That means we have a full traceability from the initial raw material until the finished good that we can deliver to our end customer.
Yeah, exactly. With all process data, all test data, all fault information, all rework action and so on. So everything is well documented and available with some clicks.
And even the production compliance can be ensured because everything is traced and transparent stored in the system.
Yeah, and as well the compliance with the quality and product criteria. And as mentioned before, we are producing according all given specifications. Yeah, and we have the application of data analytic tools for predictive control of production process with our IoT Edge solution, because that is one of the main benefits. We mentioned it already in the webinar number 3 is recommended on the 8th of February. And yeah.
And at least we have a performance management because we can trace what is going in our production and what is happened there and what is coming out of it.
Okay, so that a summary for the benefits, which benefits are deriving if you are using our solution. And now we are coming to the next point, and that's probably, the Q&A session. And so let's see if some questions have been raised by the audience. So yeah, there are some questions here. Not so much, but we will answer the questions here. Are there any special implementation requirements? Would you like to answer the question, or should I answer the question?
The thing is, what kind of implementation requirements are they up to? So from the view of the process, we can implement batch processes and the processes of a singleized ID of a serial number. But do you think there is something more?
No, I don't think that there's something more. It's based on the technology, though we need to have a bidirectional integration because we are not only collecting data, compliance management or interlogging, or you can also call it digital poka-yoke, needs to have a bidirectional integration into every machine or into every manual workplace. It doesn't matter if it's an OPC connection for a PLC, if it's a high language based integration directly on the .NET base, for instance, or if we are communicating with the already installed and used line controller. Yeah, what else do we have? Yeah. Oh, that's an interesting question. I like it. What is the impact of compliance management on cycle time? So yeah, maybe I will answer this question. So for sure, if you are working in a highly automated environment and you need for every communication, for a status check, for an interlocking, you would may need, let's say, 2 seconds, and you have 15 process steps. So that means you would slow down your production by additional 30 seconds. So that means the system, the MES system, needs to be really fast. Fast means the transaction time for a status check when you're checking the previous work step, or when you're going to assemble a sub-assembly in the final assembly, or when you just retrieve some parameters. That needs to be really quick. And quick means usually below 100 milliseconds. So that there's not really an influence on the cycle time. And that's given by our system. So from that point of view, there is no issue to be expected on the cycle time, because usually that amount of second or milliseconds is available for communication. Okay, what else do we have? What do you think? What are iTAC's USP in the offering for the battery production in comparison with the competitive landscape?
Well, I think at least one of the biggest points you already pointed out in the chapter of the pain points for the battery production. So we could say we have a starting batch production and subsequent the production of a serialized product, and we can combine flexible all the processes in one system and have a traceability from the start until the end. With the end is the delivery of the finished good.
Okay, great. Well, one more very detailed question comes up here. Are you able to collect and add relevant information for building automation via Modbus RTU and or BAC net IP? So that's very detailed question. For sure, we have our API library, which is open, and that's always the base for the communication in direction of the application server and finally in direction of the database. And there could be a certain layer between the shop floor. That could be an OPC or a connector, OPC OA. That could be also a special integration to Modbus RTU. That would be possible as well, but that's not standard, but could be developed easily. Okay, I guess that all the questions which are raised by the audience here, and then we would close the Q&A session for the moment. And yeah, we would like to give an outlook again to the upcoming webinars. So that means the next webinar would be on the 8th February about IoT, as already mentioned. And yeah, then if you have further questions after our webinar, for sure, you can reach us. You can reach out to us at info@itacsoftware.com. And maybe one additional comment: if you failed to participate right now on the live session, we've made a recording from our webinar today, which could be provided if you want on request. Yeah, we thank you very much for your kind attention and say thank you and goodbye.
Thank you.